This is my second application that I will demonstrate in my series on desktop applications. Like the previous application, it's a product management system that works in a warehouse environment for logistics, inventory and reporting operations. Where this application differentiates or is different to the previous application is in the fact that it is an Enterprise Java Beans application. It's a JavaFX front-end that uses Weld CDI injection to provide an Enterprise Java Beans framework. That is, a set of annotations that we can use to provide Enterprise Java design patterns in the code. This application also stands out because it has a way that it can be delivered to the client that's known as WebStart or JNLP. This application was developed for a roofing company in the US known as the Belden Roofing Company. So it has some features which I'd like to highlight. So it has animations for resizing the screen for the user. So here we have a resizing animation. And it has a history where the screens that you use and visit are recorded so you can navigate easily between the screens. So I'll just demonstrate that. So we'll go to a data entry screen. This is data entry screen. We'll go to a different data entry screen. And then we'll go to another. This is an account management screen. And you can see as we navigate between these screens using the menu, we have this recent activity list. And we can change between the screens in this list. So this allows us to more easily navigate through the application. So now I'll talk about the features in the code that make this particular application interesting. This is the code base for the application, which is a multi-module Gradle project. The main source code is in the client module, but there are two supporting modules. One is a Gradle plugin, which handles the way the application is delivered to the client, and a web module, which allows us to mock out and test and develop against the way the application is delivered to the client through this technology known as Java WebStart. Now this is an Enterprise Java Beans project. So the client is based on Enterprise Java Beans and it works with a remote Glassfish server which has its own set of Enterprise Java Beans. It's using the JBoss implementation of Enterprise Java Beans known as Weld. Look at the source code, we can see in the resources we have the typical Beans XML which you use with Enterprise Java Beans. Here we are bootstrapping the context dependency injection via Weld. The other main technology is the way the source code is delivered to the client via Java WebStart, sometimes known as JNLP. And we have this web module here that runs via an embedded Glassfish container. So we'll run that now and we'll demonstrate the Java WebStart or JNLP, the way the source code is delivered to the client. So now we have a JNLP servlet that's exposed via embedded Glassfish server. Here it is here. Now when we click on the launch, we will bootstrap the Java WebStart JNLP process, and when we bootstrap that process, it's going to download a whole bunch of digitally signed artifacts, which is the runtime jar of the source code for the project and all its dependencies. They will be delivered by WebStart JNLP. So when I click on launch, it's going to start that process of downloading all those digitally signed artifacts. Asking me, do you want to run this process with Java WS or Java Web Services? I click OK and the process starts. When Belden brought me in to work on this project, they already had an Oracle database with all their data on the back end, and they had an Enterprise Java Glassfish server set up so they could talk via REST to their database. Then they wanted this client, and they had initially set up an Eclipse project without any sort of dependency management. They just had basic Java code. They realized they weren't going to be able to develop to the complexity of the application they needed. So they brought me in to help them get to the end. So as they were already quite familiar with Enterprise Java Beans, I chose Enterprise Java Beans to help lay out and put the application together. The way Enterprise Java helped was in two ways. The first way was injecting objects. So here we are, injecting some sort of periodic process or activity cron job, and also injecting into the view layer. So here we have a typical service layer object that deals with data related, CRUD related operations with the data, and we inject that into the view layer where we have all our view code. So that's pretty standard Java injection. The other process that we got from Enterprise Java that was really useful was the event bus. So we broke the event bus down into a publish subscribe system, and we had a custom annotation we developed allowed us to qualify the subscribers so we could subscribe to a particular topic. When remote database was downloaded to the client, they call that process syncing, so we set up a bunch of sync topics, obvious topics, the start of the sync process, the completion of the sync process, errors in the sync process, and when we need to update or run the syncing again because the remote data has updated and we want to sync the local copy of the data. Via enterprise injection and event bus, we're able to get to the place that they wanted to be to create the sort of complexity they needed in their content resource management system. Now this application was put together end 2017, beginning 2018, and at that time Enterprise Java was not such a bad choice for code injection. Since then things have moved on, and now it's a much better choice in many ways to use Spring Boot and Spring Injection, and a lot of my later applications have leveraged Spring Boot for the code injection. But I've really missed the enterprise bus, I've really missed the event bus, and if you want to have an event bus in Spring Boot, you've got to sort of roll your own, which is a lot of work, and the Enterprise Java event bus is really useful, and this application leverages the Enterprise Java event bus in a really useful and helpful way. The final thing that stands out in this particular application was the work we did putting together our own custom Gradle plugin that we used to handle the repetitive routine tasks involved with Java Web Start and JNLP. And those tasks base around digitally signing the dependencies, then compressing the dependencies for the JNLP download. This is what all the compressed dependencies look like. So these are all compressed files that have been digitally signed and packaged together with a JNLP file, which is an XML file which tells the XML server that all of these dependencies compressed exist, and which one is the actual application dependency, which ones are the transitive supporting dependencies. So they all go into the Web Start process as these digitally signed compressed objects, and then they get downloaded and unpacked and verified through the JNLP process, so the security and malicious sort of jars can't sneak into the system. We put all that code together as a Gradle plugin, written in Groovy, and to write a Gradle plugin is not that particularly difficult. So here we have our task defined, and this is the sign jars task, and this is most of the work is in this task, which actually gets all the dependencies and compresses them, digitally signs them with the key, and packages everything up ready for deployment. So if we go to our web module, here's our web module, and we have the typical web app directory. So we find the web app directory. In the web app directory we have our web start folder. We have this dynamically created JNLP file, which is created by our plugin, and then we have the actual artifacts. So here's all those artifacts generated by our Gradle plugin, all set up in our web module, in our web apps directory, ready to be deployed into a Glassfish server. So we had our local embedded Glassfish for testing and development. Then there was the remote Glassfish server where all these dependencies and artifacts ended up ready to be set up for the JNLP delivery to the client.